Good afternoon. Today we are going to see the eccentric connection, and that eccentric connection we require for Gantry Girder. So now we have this problem already we have seen. Already yesterday I uploaded the video related with this Gantry Girder, and part I have considered till we have that is maximum shear force, which is my reaction. So now this is a reaction 341.90 kilonewton, and that we have to consider when we are going to design the eccentric connection. Now how we will have this connection? So you can see we have this as column. So this is flange width. So generally we are going to consider column minimum 350 and above. That is required if we have gantry girder over there. And then we have 350. So generally we have this value that is 250 flange width. And then we have this as bracket. On this bracket, we have gantry girder. Now in our problem, we have this as ISMC 250. So you can see we have this becomes now 125. If we will consider 350, then we have 250 around we have this width of flange. So we are going to be with this as 125. 350 or we can say 300. So whatever it may be, so it will be around 250. So let us we have 250. So we have this as 125. So this 125, this 125. So I kept this 50 as a cover. This may be reduced if my column size will increase. So if column size increases, then automatically my width of flange increases and this cover may be reduced. So now we have this as ISHB. Column you have to always keep in mind. We have to provide ISHB. As we have seen for gantry girder, we are providing this as ISWB because width of flange is greater one. So we are going to be with this as 0.3 meter, which we are going to consider it as eccentricity. And you can see over here, so we have this as 341.90. This is reaction. And 0.3 we have that is our lever arm, 0.3 meter. And then we are going to be axial force 341.90. And moment we have 341.90 into 0.3, 102.57 kilonewton meter. So let us provide 6 bolts of 25 mm diameter. We are going to consider 140. If we will consider this as 250 mm, then automatically my end distance, this becomes 55 and 55. Then we have 100 mm, that is distance between the bolts in vertical direction gauge, we can say it as. And then we have this will be R, which is distance from the CG of the group to the center of the bolt. So we have this distance, that is R, and this we require to find value of force due to moment, and this R we have to always take of the farthest bolt. Then we have two forces in the bolt, one due to axial force, and that is axial force in bolt equal to axial force in bolt, axial force divided by number of bolts. Means we are going to design this for two. One will be the axial force, which will be 341.90, which is equally shared by all bolts. So we have 6. And second, we are going to be with moment. And this moment we have calculated 102.57. So this connection we have to design for these two values. So force in bolt due to axial force is equally divided, and that will be 56.98 kilonewton. Now due to moment, we have mr upon r square. So r I already mentioned, distance of the farthest bolt from CG of the group. and that is 70 square plus 100 square, 122.07 millimeter square. R square, now we have these two bolts are along the CG of the bolt group, and therefore we have directly 70 square. But for this, we have 70 square plus 100 square. So 4 bolts, that is 1, 2, 3, 4 are at same distance from CG of the bolt group. And this value we will get it as 69400 millimeter square. Then force due to bending in bolt, that is M into R. This is moment in kilonewton meter. So into 10 raised to 6. So this is M in Newton millimeter now. Into 122.07. So we have this as 122.07 R upon R square, 69400. And from this I will get 180.41 kilonewton. Now see, I will just draw the diagram and then you will understand how these bolts forces are acting. So we have, this will be my force, bolt. Now bolt we have over here. Now we have one bolt which will act in vertically downward, and that is equal, and that value we have 56.98. So we have this value, that is 56.98. So we have 56.98. And second, we have perpendicular to this lever arm. So perpendicular to this lever arm. So just I will rub this. So perpendicular to lever arm, and that is in the direction of the moment, means it should provide again clockwise moment, because we have to design this for vertical force and moment. This already we have seen. Moment is 102.57 and axial force we have 341.90. Now we have to consider two components of this. So I will just change the color. So two components, one will be vertical and second we have that is horizontal. Now we can find this angle theta. So we have this as theta, this is 70 and then this is 100. And therefore we will get theta equal to tan inverse of 100 by 70. And this theta comes, so tan inverse of 100 divided by 70 and it comes 55 degrees. Now we have this as 35 and again we have this angle as 55 degrees. So vertical component we will have, this is my force 180.41. So now vertical component we have, vertical component 180.49 into cos of 55. And then we will get it as cos of 55 multiplied by 180.49. It comes 103.5. And horizontal component we have 180.49 into sine of 55. And we will get it as 180.49 into sine of 55, 147.85. So now you can see this. So we are already this 56.98. This force we are acting vertically downward, and we have to add this vertical component 103.46 actually, if I will consider this angle exactly. And then we have 147.78. So 147.78. So I have this angle 55.07 if I will consider, then we are going to get these above values. So from this I will get this as vertical and this is horizontal, and that will gives me 218.13 kilonewton, which will be resultant. You can find this force by using formula actually, that is Fa square plus Fb square plus 2 Fa Fb cos of theta. Then also you will get same answer over here, because this formula we have derived by using this only. Now we have to see the bolt value. So we have taken 25 diameter bolt. Now I have considered here bolt class 5.8, because this value is very large. Let us, I will check by taking this 5.8, and then we have 113.36 kilonewton due to shear, and then due to bearing. Now I will not go in detail with this. KB, I will get it as 0.68, and from this I will get VDPB, that is 170. So it is large one. So we have bolt value 113.36, and which is less than 189.19 kilonewton. So this is very large force, and I have bolt value very less. So instead of going 8 bolts, I will have directly 10 bolts now. So now you can see I have 10 bolts, and from this we are going to get different values. Now we have as 10 bolt. So actual force in bolt we will get 34.19. Or now farthest bolt we have this one. So this is 100 plus 100, 200 square. So we have this distance as 70, and this we have 200. So 70 square plus 200 square, and that we will get root 2118.89 millimeter. R square. Now again we have 2 bolts which are along the CG of the bolt group. Then we have these 4 bolts, 1, 2, 3, 4, and we have these are at 70 square plus 100 square, and these 4 bolts, if I will say this is 1, 2, 3, and then 4, and these are at 70 square plus actually we have 200 square, and then from this we will get this value as 249,000. And now knowing this value of R square, we are in position to find force due to bending of bolt. So now we have 102.57. This is again moment. And then we have R211.89 divided by R square 249,000. And now if we will see force due to bending in bolt is 87.28 kilonewton. Now you can see now we have again in this fashion. So we have this. Then we have force vertically downward, which will be 34.19. And second force we have perpendicular to this. And this force we have 87.28. Now, theta we have in this case. So I have this distance as 70. I have this distance as 200. And theta I will get it as shift tan inverse 200 divided by 70, this value comes 70.71. Theta we will have 70.71. Now I will get 2 component of this. One component I will get it as vertically downward, and this will be cos value 87.28 into cos of 70.71. It is 28.83. So this is 87.28 cos of 70.71, and this value we have 87.28 sine of 70.71. 87.28 sine of 70.71, 82.38, and from this I will get value 103.72 kilonewton. So we have this will be second component. So second component 82.38, and vertical component we will get it as 28.83. And from this I will get this value resultant bolt. You can calculate this value by using this, that is 34.19 square plus 87.28 square plus 2 into 34.19 into 87.28 into cos of 70.71. And from this also you will get same value. And knowing this value, so we can calculate it 34.19 square plus 87.28 square plus 2 into 34.19 into 87.28 into cos of 70.71, and root of this we will have 103.72. And this value we have actually less than 113.36 kilonewton, which is my bolt value. Bolt value is not going to change, and therefore our requirement is satisfied, and we will provide 10 bolts. Provide 10 numbers, 10 bolts of 25 mm diameter. 25 mm diameter. And this will be my connection which we required for gantry girder. So today we will stop here only. Remaining part we will see in the next lectures. So thank you.